A very good evening to all. Today I am going to explain you about the three-phase induction motor working. So as we know, a motor is a machine which will convert the electrical energy to mechanical energy, and since it's an AC motor, the electrical input is said to be AC. The most commonly used type of an AC motor is induction motor, and hence today we are going to discuss what is the working of a three-phase induction AC motor is. So this is the general pictorial representation of the three-phase induction AC motor, which consists of the main constructional features like it is having a shaft, it is having a stator and also a rotor. The stator is the stationary part of the induction motor and rotor is the rotating part of the induction motor. The stator consists of three other constructional part, that is the stator frame, stator core as well as the stator windings. Here the stator windings will be a three-phase windings because it is a three-phase induction motor, and the rotor consists of two different types based upon the construction. It can be either a squirrel cage induction rotor or it can be phase wound or slip ring induction rotor. So as we know, the most widely used electric motor in the industry is three-phase induction motor. So three-phase supply is given to the stator and the rotor starts rotating. It has two major parts. One is the stator, which is the stationary part, and rotor, which is the rotating part, and it runs initially at constant speed from no load to full load. Both the stator and the rotor will have the slots in order to keep the windings, and the windings which we are connecting will be a three-phase winding which we can connect either in the star connection or in the delta connection. So as we know, since it's having two major parts, that is the stationary part which is the stator and the rotating part is the rotor, three-phase supply is usually given to the stator windings. Now let's learn what is the principle of operation of a three-phase induction motor is. It's normally creating a rotating magnetic field. I will explain you what is a rotating magnetic field later on. First, let us understand what we mean by the synchronous speed. That is, the stator will be rotating at a speed, and that speed of rotation of the stator field is defined as the synchronous speed, and which is usually determined by the frequency of the supply voltage and the number of poles. The synchronous speed is given as 120 F divided by P, where Ns denotes the synchronous speed in RPM, rotations or revolutions per minute, and F is the frequency in Hertz, and P is the number of poles. Now let's understand what is the principle of operation of a three-phase induction motor is. That is, here we are having a stator and the stator is connected to the three-phase winding. So the stator naturally develops a flux through the air gap and it sweeps past the rotor surface and cuts the rotor conductor. Due to the relative speed between the rotating flux and the stationary rotor conductors, an EMF is induced in this rotor conductors. Since the rotor windings are shorted and are closed through some external resistance, like the case of a slip ring induction rotor, the induced EMF causes the current to flow in the rotor conductors. This produces an induced current, and that is the relative motion between the rotating magnetic field and the stationary conductor. According to this, the Lenz's law, induced current will try to oppose this relative motion by producing torque such that it rotates the rotor in the same direction as the stator flux. The rotor never exceeds in catching up with the stator field. If it really does so, there is no relative speed between the rotor and the stator, and hence no rotor EMF or no rotor current, and hence no rotor torque is produced to maintain the rotation. So the rotor runs at a speed which is slightly less than that of the speed of the stator field or the synchronous speed. So what is happening is we have a three-phase winding in the stator, and this three-phase winding in the stator will actually produce an alternating flux. Since we have three-phase winding, suppose my phase A is the reference phase, phase B is lagging with respect to my reference phase by 120 degree, and phase C will be my third phase which is lagging my phase A with respect to 240 degrees. So these three phases will individually produce an alternating flux, and each of this alternating flux will be constant in magnitude, but it will be varying with respect to the position because we are having a three-phase system. So this three alternating flux will produce a net alternating flux, and that net alternating flux will have constant magnitude, but it will keep on varying with respect to the position. So that will naturally produce a rotating magnetic field, and there is a relative motion in the rotating magnetic field with that of the rotor conductors, which will induce the current in the rotor conductor. So as per Faraday's law of electromagnetic induction, whenever a current carrying conductor is placed in a magnetic field, what will happen is an EMF will be naturally induced. So this rotor conductor currents will naturally induce an EMF in the rotor, which will thereby produce a torque in the rotor conductors, and that will make the rotor to rotate. But what we have to know is the rotor will be rotating at a speed which will be less than that of the synchronous speed of the stator field, but both will be rotating in the same direction. So the principle of operation of the rotating magnetic field is being shown here, where we have three phases, that is R, Y as well as B. So each of the phase will be producing a separate flux, and this separate flux will be constant magnitude and will keep on varying with respect to the position. So that is what is being shown in this figure. Now next is to understand what is slip in a machine is, that is, we have both speeds, that is the synchronous speed as well as the rotor speed. The difference between the synchronous speed and the rotor speed we define as the slip speed, and the slip speed is usually expressed as a percentage of slip, which we define as percentage slip, which is the ratio of ns minus n of ns into 100%. Suppose my s is equal to 0 means what will happen is my ns will be equal to n. When n is equal to ns means the motor is running at the synchronous speed. Suppose my slip is equal to 1 means what will happen is ns is equal to ns minus n. That means n will be equal to 0. If n is equal to 0 means my rotor speed is said to be equal to 0. That means my rotor is not rotating, it is said to be stationary or at standstill. So what is slip is? It is the difference between the synchronous speed and the rotor speed. The ratio of synchronous speed to the rotor minus the rotor speed to the synchronous speed is defined as the percentage slip. Now we have discussed what is the working of a three-phase induction motor is. So why we define this as an induction motor is, it is basically working on the principle of electromagnetic induction. So due to that reason we generally define an induction motor. That is, in an induction motor there is no electrical connection between the rotor and the stator. The current is induced in the rotor, and that is due to the stator flux. Just like an EMF induced in the secondary winding of the transformer when the flux linking with the primary changes. The rotor EMF or the current is produced due to the electromagnetic induction, and that is why we define this motor as an induction motor. The induction motor can be considered as a transformer with a rotating secondary. So in this presentation I have just explained you what is the basic working of a three-phase induction motor is, which is governed by means of a rotating magnetic field, and also its constructional parts, and as well as why we define this motor as an induction motor. Thank you.